15, 20 years old. I don't know. It's the sample data in SPSS. Maintenance or custodial earned $31,000 with a standard deviation of 2, so much smaller standard deviation than clerical. And then managers earned $64,000 rounded, and a much larger standard deviation of 18,000. Now in SPSS, you get the test of homogeneity variances. That's an assumption of analysis of variance in conjunction with the dependent variables measured on a continuous scale. You also assume that the variances or standard deviations are equal within sampling variation, and SPSS is telling us that that is definitely not the case, which happens very often in real-world examples. If we continue down, we get the ANOVA test, which is the main test of analysis of variance. It's called analysis of variance. I don't want to make this into a lecture, even though most people probably would call it an analysis of means, because what we're interested in is the difference in the means. But really it's an analysis of variance because it's examining the variability amongst the means and compares it against the variability within each mean in terms of the individuals within each group. And that's why it's called an analysis of variance. In this case, the F value of 434.5 is statistically significant, p less than 0.001. But my test of homogeneity variance is statistically significant, which is telling me that the variances within each group are statistically different from each other. At least this 18,000 is different from the 2,000. It could also be different from the 7. It's just saying that at least one comparison between the two, between the variances, is statistically significant. And that's why it's important to look at the robust tests of equality of means, of which SPSS in this option gives you 2. We can look at Welch's and we can look at Brown-Forsyth's tests, and they're slightly different approaches. Welch is closest to what the ANOVA is actually doing, except that it actually accommodates heterogeneous variances, and it also accounts for heterogeneous variances. I would say it probably accommodates heterogeneous variances more than it accommodates for heterogeneous differences in sample sizes. I'll probably go into that into a separate video about how important unequal sample sizes can be in your analysis. But the Welch's statistic is statistically significant, and we can see that the degrees of freedom are actually quite different. In fact, that's part of the Welch's procedure, is it adjusts the degrees of freedom. Over here, within the error degrees of freedom is 471, whereas the independent groups, in the numerator the degrees of freedom is 2. This is the numerator degrees of freedom of 2, and it's been the degrees of freedom in the denominator have been adjusted quite substantially. There are also other adjustments that take place in the Welch's test, but the vote of confidence here is that it's also p less than 0.001. SPSS doesn't give it to the 4/5. I could adjust it here to actually get the significance level at some level of a decimal place, but we'll just know that it's p less than 0.001. Now Brown-Forsyth is also finding a statistically significant effect, and the added bonus of the Brown-Forsyth procedure, in addition to unequal sample size and unequal variances, is that it also gives you more protection against non-normally distributed data in your dependent variable. At least I've read that once or twice in a resource here or there. And it kind of makes sense to me because the Brown-Forsyth procedure is actually using the median, differences between absolute deviations between observations and the median to help estimate variability in the data. And median is usually less susceptible to differences in normal distributions versus non-normal distributions. Anyway, the important point here is that we've got 2 tests that help us back up our significant effect here, and because we have statistically significant different variances, we use the Welch and or the Brown-Forsyth to help us reject the null hypothesis and be confident that there actually is a statistically significant difference in the means. Now we look at the plot here, and we can see that the means go in the direction that we expected. We'd expect managers to earn fairly substantially more than clerical and custodial employment categories. But what we don't know, at least as a trend, but we don't know if